Alright, welcome back to Scholar's Drive. We're doing some math. Today we'll be graphing general rational functions and then look at a nice little summary list on how to graph these suckers. So number one, y equals 6 over x squared plus 1. So remember, rational function is a polynomial over polynomial. So in number 2 and number 3, you can see the different sizes of polynomials we can use. So the first thing, what you want to do is factor anything that you can. So number 1, we can't factor because x squared plus 1 on the bottom can't be factored. It's in its simplest form. A whole, we'll explain this later, but a whole is when we have something in the denominator and it cancels out with something in the numerator as we're factoring. And that's where a whole would be. But in this case, we don't have any wholes. Vertical asymptote. This is when this is when the denominator, you set the denominator equal to 0, and we get a value. And in this case, we don't have anything, because if you set x squared plus 1 equal to 0, we'll get x squared equals negative 1, and when we try to take the square root, we'll get I, and I is imaginary, so none. Horizontal asymptote is at y equals 0. So remember, we have a vertical asymptote at so I started with the wrong page first. We should start on this page, which tells you everything you need to know on how to graph these things. So what we did first was we factored the equation. We couldn't factor. Second is wholes. This is what I told you. If you found, when you're factoring, if you found something that could cancel in the numerator and the denominator, that's where it causes a whole. Vertical asymptotes are when you look at the denominator, set it equal to 0. If there's any factors down there, that is your vertical asymptote. Zeros are all factors in the numerator, and then you set that equal to 0, and it doesn't cancel with anything in the bottom. And then horizontal asymptotes, they have some special things here. So you look at the degrees of your your function and the numerator and the denominator. So example, we have this one here, y equals x over x squared. The degree of the top, that means the highest exponent is 1, and the degree of the bottom is 2. So if your degree is higher on the bottom, then the horizontal asymptote is just y equals 0. So if the degree is larger on the bottom, just set it equal to 0. If the degrees are the same, then you use y equals ab. So in example 1, they have degree 2 because they're both x squared. So we just use the leading coefficients a and b, 2 over 1. And then in example 2 here, we have negative 1 up top and then 4 on the bottom. Now what if our numerator is bigger than our denominator? Then it has no horizontal asymptote, but it actually is a slant line instead. So let's draw in this example here. 3x squared plus 2 over x minus 1. Okay. And our equation is y equals a over b x to the m minus n. So where m is the degree of your numerator N is the degree of your denominator. Okay. And then we have A, B, or actually, sorry. X squared plus 2. Okay. So, if we put in our formula here, A over B is 3 over 1, just the leading coefficients. So, 3x m minus n. So, the degree of the top is 2 minus 1. So, y equals 3x. That is our horizontal asymptote. Or not horizontal, it has a slant asymptote. So hopefully we don't run into too many of these examples, but it's where your top degree is bigger than your bottom. So you take the leading coefficients, divide them, so A over B, and then times it by x to the m minus n, and that is your slant asymptote. Alright, so let's go back. So these rules for the horizontal asymptote is quite difficult to remember, but know if the bottom degree is bigger than the top degree, then y equals 0. If they're equal, just A over B. If the top is bigger than the bottom, then you got to use this fancy formula here. Then plot the y-intercepts, and then plot. So let's go back. So once again, we can't factor it. There's no holes. Vertical asymptote, none. Horizontal asymptote. The bottom degree is bigger than the top degree, so y equals 0. The real roots, your x-intercepts. So you set the numerator equal to 0, and we got none. So our y-intercept is when we set x equal to 0. So set x equal to 0. I'll get 6 over 1. So 0, 6. Okay. And now we're just going to plot. So 0, 6. It's our y-intercept. We don't have any holes. We don't have any vertical asymptotes. We have a horizontal asymptote at y equals 0. Okay. And we're just going to go ahead and plot some numbers. So make an x and y table. 0, 6. So let's try, let's just do the basics. -3, -2, -1, 0 we know is 6. 1, 2, 3. So 1 is 3. -1 is also 3. -2 is 6/5. +2 is 6/5. So this is actually very symmetrical. 3/5, 3/5. So it's going to do this. 1, 3. -1, 3. 2, a little bit above 1. And then under 1. So we know it never touches 0. So it probably does something like that. Alright. So, number 2, let's factor. So let's factor the top. Two numbers that multiply to -4 and add up to 3. That would be x minus 1, x plus 4. And then on the bottom, we just have x minus 2. So it's factored. We can't do anything. So holes, nothing cancels out, so there's no holes. Vertical asymptote, we look at the denominator. So the denominator is x minus 2. So you set it equal to 0. So my vertical asymptote is at x equals 2. Horizontal asymptote, the so the numerator's degree is bigger than the denominators. So we have y equals a over b times x to the m minus n. So y equals, so we look at the coefficients here. So we have 1 and 1 here. So that's just x to the m minus n. The degree of the top is 2. Degree of the bottom is 1. So 2 minus 1. So this is just y equals x for our slant asymptote. And then our real roots, you set the numerator equal to the top. So we have x minus 1 equals 0 and x minus 4 equals 0. So we have x equals 1, x equals 4. So that would be 1, 0, and 4, 0. Oh, sorry, this is a plus 4, so that's a negative 4. And then our y-intercept, we set x equal to 0. So we'll get negative 4 over negative 2. So plugging in the equation, x is 0. So y equals positive 2. So this is, this is when x is 0, y is 2. So let's graph that one. So we have vertical asymptote at x equals 2. We have a slant asymptote at y equals x. So we just draw the line y equals x. Okay. Oh, this should be more like this. Okay. Then we have an x. We have x-intercepts at 1, 0. So 1, 0, and negative 4, 0. Okay. Now let's punch in some points. So x, y. So this is where you kind of just have to get random with it a little bit. So 3 is 14. 4 is 12. 5 is also 12. And 6 is 12.5. So 3. Wait a minute. Oh. Okay. So it's kind of weird. So this is all really high up. But I was basically kind of doing something like that. And then on the bottom here, it has something like this. So punch in numbers until you get something. But it kind of looks like that. It's kind of weird. Alright. Last one. Okay. Numerator. So factor first. So I'm going to factor out a 6. So I got 6x squared plus 6x. Oh, not plus 6x. Factoring out a 6. Plus x minus 2 over 3 x squared minus 12 or 4. In which this becomes, just going to go ahead and reduce now. So 2 times x plus 2, x minus 1 over x squared plus, or x plus 2, x minus 2. Okay, wholes. So these cancel, so that's where our hole is at x plus 2 equals 0. So x equals negative 2, that's our hole. We have a vertical asymptote, so the denominator equals 0 and it's not equal to any holes. So we have x minus 2 equals 0, so x equals 2. Horizontal asymptotes, they are of the same degree, so it is just, what was that again? If they are the same degree, then the horizontal asymptote is at y equals a over b. Okay. So a is 6, b is 3, so this is y equals 6 over 3, so y equals 2. Real roots, you set the top equal to 0, and it's not a hole, so x plus 4 equals 0, x equals negative 4, so that's negative 4, 0. Right. Oh, I messed up. Sorry. Looking at the wrong problem. Yeah, down here, we set the top equal to 0, so we have x plus 2, x minus 1, x plus 2 made the hole, x minus 1 did not make the hole, so we set that equal to 0, x equals 1, so 1, 0. And then y-intercept, we set x equal to 0, and we'll get negative 12 over negative 12, which is 1. So this is 0, comma 1. Okay. So we have vertical asymptote at x equals 2. Okay. And then we have a horizontal asymptote at y equals 2. Sorry. And then we have a point at 1, 0. And we have a point at 0, 1. So we can get the idea that it looks like this. Not so bad. Oh yes, we have a hole at negative 2. So all we do is look at our graph and then draw a circle. That represents our hole. It means nothing exists there. It's just like a break in the line. And then this top one kind of looks similar to this. You just punch in numbers. Okay. So we're going to stare back at this list again. If you have this list, please follow the steps here. So you factor the equation. Holes is when stuff cancels out. Vertical asymptote deals with the denominator. You set it equal to 0. And that's what x is. And then zeros are in the numerator. setting the numerator equal to 0. Horizontal asymptotes, there's 3 different situations. And then plot the y-intercepts, and then make an xy table for the rest. Hopefully this is not too confusing. I know it's the whole holes thing, the horizontal asymptote, which situation, especially this last equation here. That's rough. I'm gonna go check if I have any more examples. Otherwise, have a good day.